Imagine a world where machines can not only perform their tasks, but also build and improve themselves, creating an ever-advancing technological society. Sounds like science fiction, right? Well, it's actually closer to reality than you might think. In this video, we'll explore several remarkable self-replicating machines that are either already here or on the horizon, from AI-powered robots to molecular nanobots. So let's get started. 1. Autonomous reproduction. We're starting with the most straightforward form of self-replication, where machines copy or assemble themselves with little to no human intervention. Think of it like a self-driving car that can not only drive itself, but also manufacture identical copies of itself. This concept is being explored by various companies and research institutions, including a startup called Automata. Their goal is to create an autonomous factory line of modular robots that can reproduce themselves indefinitely, opening up new possibilities for manufacturing and assembly tasks in various industries. 2. AI-driven evolution. This takes the concept of self-replication to the next level by harnessing the power of artificial intelligence to create improved versions of themselves over generations. Through generative design and machine learning, these AI systems can analyze their own performance and design flaws, then use that knowledge to create offspring that are better suited to their environment or task. This could lead to the development of highly efficient and adaptable machines that can solve complex problems in ways that humans couldn't even imagine. 3. Space colonization. As humanity sets its sights on colonizing the moon and Mars, NASA is exploring the use of self-replicating robots to construct and maintain bases on these celestial bodies. Self-replicating rovers and construction bots could be deployed to build habitats and other infrastructure that humans need to survive and thrive in these harsh environments. This would not only reduce the cost and complexity of space missions, but also enable us to explore and settle distant worlds much faster. 4. Von Neumann probes. These hypothetical interstellar robots are a fascinating concept that has captured the imaginations of scientists and science fiction fans alike. Proposed by mathematician John von Neumann, these self-replicating probes could be sent out into space to explore and map distant star systems and planets. Using resources found in space, such as asteroids, they could replicate themselves and create vast networks of exploring and mining. Robots that would greatly advance our understanding of the universe. However, as with any powerful technology, there are risks involved, and many experts have warned of the potential dangers of creating self-replicating machines that are not under human control. 5. Molecular nanotech. In the realm of nanotechnology, the ability to create self-assembling molecular machines is a holy grail that scientists are working towards. Imagine a future where tiny nanobots could self-assemble at the atomic level to create more complex structures, such as medical microbots, that can diagnose and treat diseases within the human body. Self-assembling nanostructures could revolutionize fields such as medicine, manufacturing, and energy storage, but it remains to be seen what challenges we will face in developing this technology. 6. Self-repairing systems. Self-repairing systems are another practical application of self-replication, where machines can identify damage to themselves and then use 3D printing or other additive manufacturing techniques to create replacement parts and repair the damage. This could be especially useful in fields such as aerospace and military, where equipment needs to be highly reliable and maintainable. For example, a damaged satellite could use self-repair capabilities to fix itself and continue operating. To prevent any possible negative consequences, safeguards, such as built-in-off switches or other constraints, can be implemented to ensure that the replication process does not go out of control. For instance, a self-destruct mechanism could be triggered if the machine starts replicating uncontrollably, or if it detects that its replication is no longer needed. This way, the potential for disaster is reduced, and the benefits of self-replication can be enjoyed without the risk of a Terminator-like scenario playing out. Another challenge associated with self-replicating machines is the need for a sustainable power source. These machines require energy to function and replicate, which means they need access to things like solar power or nuclear energy. Without a reliable energy source, self-replicating machines may not be able to function properly or replicate as intended. Despite these challenges, Self-replicating machines hold tremendous potential for advancing technology and helping us tackle some of the world's biggest problems. As we continue to explore and develop this technology, it will be important to consider the ethical and safety implications and ensure that these machines are developed and used responsibly. One area where self-replicating machines are already being researched is in the military. DARPA, the Defense Advanced Research Projects Agency, is exploring the use of self-replicating drone swarms for surveillance and reconnaissance missions. The idea is that a small swarm of drones could be deployed to an area of interest and then use self-replication to create more drones, increasing the size of the swarm and improving its ability to collect intelligence. However, as with any military technology, there are concerns about the potential dangers of self-replicating drones. Some experts have warned that self-replicating drone swarms could pose a risk to civilian aircraft, and that they could potentially be used for nefarious purposes. As a result, there are ongoing discussions about the ethical and legal implications of developing this technology. And finally, one of the most significant existential risks posed by self-replicating machines is the so-called gray goose scenario. This is a hypothetical situation in which self-replicating nanobots or other microscopic machines overrun and consume all available resources on Earth, leading to widespread ecological disaster. While this scenario is often dismissed as science fiction, it highlights the importance of considering the broader implications of developing such powerful technology. As we continue to explore and develop self-replicating machines, it will be crucial to have safeguards in place to prevent unintended consequences and ensure that these machines are used for the benefit of humanity. Thank you for watching, and see you in the next video.